All right, let's go and get started by taking a look at the last problem on that handout. And we set the picture up already. Technically, I set the picture up for you there on the picture, on the handout. But let's go and look at it again. So we've got our north, south, east, west. It says a man tries to paddle his kayak not directly across the Nile River, going east to west, but rather at an angle that he makes. And this was the first time we'd seen an initial vector angled 20 degrees to the north of west. So here would be west, right? North of west would be here. By the way, let's do some practice with this real quick. Where would be south, class? Where would be east of south? Good. Where would be east? Where would be south of east? You see they're both kind of in the same location? But here's the deal. If I have 10 degrees east of south, that means I start off south and I go 10 degrees to the east. 10 degrees south of east, however, I would start out east and then go 10 degrees to the south. You see how these are both southeast. One is 10 degrees south of east, the other is 10 degrees east of south. Okay, so he's going 20 degrees, it says north of west. Well, here would be west, and we're going 20 degrees to the north of west. That's him trying to cross the Nile River in his kayak. Let's see, 6 miles an hour. Going 6 miles per hour kayaking. So the Nile River flows 4 miles an hour south to north. So it's going just straight this way 4 miles per hour. Well, remember I said if we were to draw a little parallel longitude or latitudinal line here, what would be this angle, class? 20 degrees, because these two angles are, well, no, I was thinking geometry terms for parallel lines cut by a transversal. You're in geometry. You also just had a weekend. Alternate interior angles, right? So this would be a 20-degree angle. Well, then what is the angle between the vectors? 110, because I've got a 90 between the true north and true east-west, correct? That's a 90, plus 20 more on top of that 90 gives me a total of 110 degrees. And then we've got our resultant line forming here. Zoom in just a little bit more over here. All right, so 6 is the primary, 4 is the secondary. We've got a 110 angle between them. To find the magnitude of the resultant, since these are not perpendicular, class, I'm going to need to use 2 laws. First law, Michael.
Is the law of cosines.
Law of cosines. What is the law of cosines, class? Say it with me. C squared equals A squared plus B squared minus 2AB times the cosine of C. And so the C, of course, is my resultant. So resultant equals the square root of, now you two ladies will take the square root at the end. Michael, you can do it at the beginning. The 6 squared plus the 4 squared minus, and here we'll want a parenthesis, 2 times 4, or 6 technically, times 4, not that it matters, times the cosine of the 110. We'll want to close those parentheses. We'll hit equals, then square root. He's already hit square root. He'll just hit equals. And I don't have an answer key, so I'm going to have to figure that out real quick. 6 squared plus 4 squared minus parentheses 2 times 6 times 4 times 110 cosine close parentheses equals square root. How fast does kayaker end up going, class?
8.3.
Yeah, 2 sig figs, right, is 8.3 miles per hour. Now it's actually 8.271. I'm going to store it in the memory so we don't go. Okay, and then we're going to use the memory value to find the angle. Now notice, the angle we're looking for is this angle. But when I write my final answer, I'm going to have to express it respective to an actual compass direction. So we're going to end up expressing the answer as this entire angle. So we're going to get our angle, and we're going to have to add the 20 degrees he was already off course to the angle that we now get. All right, but to find this blue angle theta, we're going to use the law of sines. Say it with me, class. A over the sine of A equals B over the sine of B equals C over the sine of C. Of course, we don't ever use, or we don't use in this class, the first part of it. B is the secondary vector. That's a 4. Over the sine of an angle B, that's the theta that I'm looking for, equals the resultant C that's in the memory value, over the sine of the angle C, which is the 110 angle between the vectors. And I'm going to take the 4 times the 110 sine, divide that by the memory value, recall 1, and then take the arc sine at the end, remember. And what is the angle off course that the kayakers pushed, class?
47 degrees.
27.0 degrees, 27 degrees. But even though he's 27 degrees off of his intended course, how far is he from west, class?
47.
That's the 47 degrees north of west. He's only 27 degrees off course, but since he was already 20 degrees north of west, he's now 47 degrees north of west. I suppose if you really wanted to overthink it, you could say he's 43 degrees west of north. Does that make sense? I mean, if it's 47 here, that's 43 there. Whatever, 47 north of west is probably the easier way to represent it. Though, there are those who would argue you want the smallest acute angle possible, and 43 would be the smaller angle. Yeah. It was starting off with respect to west. I would just stay with respect to west. All right. How many had that answer? 8.3 at 47 degrees north of west. Okay, Michael did. Ladies, do you happen to have 27 and just forgot to add the 20 on? Okay, so you were right there. And normally we don't have to add anything. It's just because he started 20 degrees off course. Okay, Audrey?
I had the 8.3, but I had 49.
All right, did you use the law of cosines? Do you have any of the work written out where you can check?
No, but I still have the memory value.
The memory value is still correct. I'm wondering if you used the 6. I'm going to check that real quick. 6 times the 110 sine divided by the memory value, take the arc sine. That'd be 43 degrees, so that doesn't sound right either. I'm sure we got 49. Yeah, I don't know. All right, unless maybe you actually, no, that wouldn't have done it either. No, did you get a 49 because you got 29 and added 20, or you just got 49 straight up, you also forgot to add the 20?
I'm not sure.
You don't know. Does it make sense now?
Yeah.
All right, let's do a couple more practice problems here. And let's review. So we said for skewed vectors, class, for skewed vectors, if we want to find the magnitude of the resultant, we use law of cosines. For the direction or the angle of the resultant, class, we use the law of sines. For perpendicular vectors, how do I find the magnitude of the resultant? Pythagorean theorem. If they're perpendicular, Pythagorean theorem. Now, technically, you could use the law of cosines. Now, this is going to lose you, pre-cal students. Cosine of 90. Cosine line, 90 degrees. 0, right? And I'm going to have a seat in the back there, Hayden. So if you were to try to use the law of cosines, you plug in that 90 for cosine 90, that whole minus 2ab cosine c all becomes a 0 anyway. So you're right back to c squared equals a squared plus b squared, aren't you? Technically you could, it's just a waste of your time to do it that way. So Pythagorean theorem, and then what do you do for the direction or the angle on perpendicular vectors? Kind of tangent, arctangent, right? So let's practice one of those perpendicular vectors again. Let's suppose a boy throws a paper airplane 4 miles per hour due south. And suppose there is a gentle breeze blowing at that time, and the gentle breeze is blowing at just 2 miles per hour due west. Find the resultant velocity of the paper airplane. if we're going only 1 sig fig like I didn't mean to do, we would have 5 miles an hour at 30 degrees west of south. If you assumed I meant 4.0 and 2.0, which I should have written, then we would have had 4.5, I cheat right there, miles per hour at 27 degrees west of south. Did we get that answer? All right, let's suppose now, same problem, but instead of the gentle breeze blowing due west, suppose our 2 mile an hour gentle breeze is still blowing, but now it's blowing at 10 degrees to the north of west. Blowing at 10 degrees to the north of west. Check your picture. Are you on the right track? Curious on something? What'd you have?
I had the right numbers, but I had the direction wrong at the end.
You had the 28 degrees.
Yeah.
Oh, okay, it was just, okay. So we see the intention is to go south, but we were just like the last problem, he was pushed to the west of south. He was still pushed to the west of south, just not quite as far. That make sense? Okay. Michael, good to go.
I had 38 degrees.
38 degrees.
Because I added 2.
Okay. Notice he was still going due south to begin with, so he wasn't already 10 degrees off of south. The wind pushed this way, which means the wind pushed a little bit against him and pushed a little bit or more of it off course. So he went off course by 28 degrees. And he was, well, I mean, the wind kind of carried him this way and it sped him up a little bit, but it also went in his face, so it didn't speed up as much as it would if it was a true west wind. Questions? Clear desk except for a clean sheet of paper and a pencil and a calculator. Clean sheet of paper, pencil and calculator. First, let's name at the top of your paper along with today's date, which is 10/10/22. 10/10/22, today's date. (10/10/22), and this is quiz 10. Quiz 10 on 10/10. All right, let's go and take a look at the quiz together very quickly. Numbers 1 through 4, you've got some multiple choice. Numbers 5 through 7, you're writing out these formulas. And then numbers 8, 9, and 10, you're solving the problems. Start with a very clear diagram of vectors and go from there, show as much work as you can. All right, you may begin.